So this is an example of repeated nearest neighbor algorithm. I've already worked out the table, but I wanted to show how I got the numbers and the circuits in the table. So for this first circuit, I start at A, and then I look at all of the paths leaving A, and I find the shortest path or shortest weight, which would be 4. And so I'll go down 4. And then with nearest neighbor, we're only looking at the paths leaving the current vertex. So for this one, we have 3 vertices leaving, and 8, 10, 1. 1 is the shortest. For this one, I have 3 leaving. 6 is the shortest, but if I go down 6, I cut off the rest of the vertices too soon. So I don't want to close my circuit yet. So I'll choose 14 instead. And for this one, I have 9, 8, and 12. 8 is the smallest, but that would come to E. We've already been to E, and it would, it's not beneficial to go to E, cutting off, creating this like circuit here. So we'll go to C. And then for C, we've been everywhere else, so we might as well just go on back to A, and that's how we got A, E, D, B, C, back to A. We can do that same idea for B. We'll start at B, and then B has 4 paths leaving, shortest one being 8. And E has 3 paths leaving, shortest one being 1. D has 3 paths leaving. The shortest is 6, so we'll go down that one. And we have 3 paths leaving again. Shortest is 4, but it's going to E. We've already been there. And it kind of closes off a circuit here. So we will go down 5. And we've been to all the vertices, so we're just going to go back to where we started, giving us our circuit of B, E, D, A, C, B. And you just kind of do this for all of your vertices. You'll do the same thing for C. Starting at C, shortest path is 5, or shortest weight. The next shortest weight is 4. And then 1. If I go down 6, I cut off parts of my graph, completing a circuit. So we'll go down 14 instead. And we've been everywhere, so we'll just go back to C, giving us C, A, E, D, B, A. It's just this one here. And we do that for all of them, and add up the weights once we get those. Let's do D, and I'll just make sure you see how to add up the weights. So D, shortest is 1, next shortest is 4, 5, 9, and we've been everywhere, so we're just going to go back to D. And our weights are those numbers on our path. And we'll add those up. And that's how we get these numbers here. And if we're looking for the shortest, we have 2 options. Both of these are 29. And we could start from anywhere on that path. If we wanted to start at D, we could start at D, and it'll give us the same path. So the path for starting at B would be B, E, D, B, E, D, A, C, B. But say I wanted to start at D instead. D, A, C, B, E, D. We just wouldn't have two B's, we'd have two D's. But it's the same path, and that would be our answer. If you're doing this problem as your My Open Math problem and it's asking you to select a letter, you're selecting the vertex that it starts with to get the lowest path, which in this case would be B and E as my answer.